Hi, my name's Joanna Hughes.
Hi, my name's Nina Spray.
Hi, I'm Kallum Tolkien.
And the project I've been working on is called Ding Dong. Ding Dong is a responsive React web application for apartment concierge services to let tenants know parcels are ready to be collected from reception. The inspiration behind Ding Dong came from my experience living in my previous apartment building. When a package was delivered, the concierge, Jeff, really great guy, would sign for it. Then he would need to manually record each package into the paper folder while running a really busy front desk. In order to notify tenants a package was ready to be collected, he'd write down on a slip of paper and post it through the tenant's letterbox to notify them. This was very time consuming and the process wasted a lot of paper each day. I had the light bulb moment, and the concierge needed a digital package management portal, offering a more socially conscious solution. Kallum and Nina loved the idea and the Ding Dong journey began. We put together a wireframe prototype using Adobe XD. This allowed us to see a basic blueprint of what we needed to build and achieve. What we see here is the first design and layout of Ding Dong. We wanted the site to be user-friendly with a simple design to help the concierge transition from a paper system to online. Here you can see where we started to add more styles and branding to Ding Dong. We wanted the design to be simple but visually pleasing to the user. We used colours.co to automatically generate a number of different colour palettes for the branding. So I'm going to walk you through how it works. The concierge would need to sign up by clicking sign up. They would need to enter their work email address, a password of their choosing, but because we already have an account, we're going to use that one instead. Press the login button. There we go. Now we are in. This is the data table that holds all of the tenants' information and the notification section. If a package was to arrive for Charlie West, and the concierge needed to log this in, the concierge simply needs to click onto the search tenant field, click search. Now we have Charlie West, he lives at apartment 5E. We now need to select the parcel size, click send a ding dong, and then we'll have this change to tenant notified. A text notification has then been sent to Charlie's mobile, letting him know that a package is waiting for them at reception. Now Charlie has his text message, he can now present this to the concierge and collect their package. I'm going to now talk to you briefly about the about page. We've kind of broken this down into what is Ding Dong, how does it work. We've also embedded a how to use Ding Dong video, and we've also incorporated a step-by-step guide. So if the concierge gets stuck, they can use this as a reference point. At the end, we have this section of the teams. So you can see we've got the hover function, and this links to our LinkedIn profiles. So the concierge also has the ability to add a new tenant. All they need to do is simply submit. So we go back to the navigation bar, click on Ding Dong, go on to search tenant. So now Sam has been registered. We wanted to incorporate accessibility into Ding Dong. We added the hover CSS pseudo class feature to the navigation bar. When the user moves the cursor over any of the words in the navigation bar, a pink box should appear. This helps the user focus their attention onto the tab they want to click on. To improve the readability, so we made the font size in the navigation bar larger. We also imported Roboto from Google Fonts, as Roboto is easier to read for people who have dyslexia or visual impairment. Just want to click log out. I'm going to pass you on to Nina.
I will be talking through the technologies we use to help build Ding Dong. First of all, I'm going to talk about React.js. We decided to use React because as a JavaScript library, it provides excellent, clear and concise documentation and displays instant results. We decided to organise our web application by components, contexts, hooks, images, requests, styles and tests. Our web application, you can see, is split into separate components. This definitely helped when working on Ding Dong as a project, as it helped to reduce merge conflicts in GitHub. The components, as you can see, are separated by distinct parts of the user interface, with app.js being the root component. Throughout the project, we used useState, useEffect, and created 2 custom hooks, useForm and useAuth. Creating our own hooks helped to make our components cleaner by reducing less code and logic throughout the application. Our useForm was created to help with state management throughout the application. We used useState in this custom hook. This hook takes the entry of the previous state and an event, which is a modifying function for the state when inputting the new values by using onChange. Then, when using onChange, it sets the new internal value of that state. This helped us to extract all the management of the changing state into useForm. Within this hook as well, I used a reset values handler, which reset the values of the state to the initial state. This can be seen on the web application when you create a new tenant. useAuth was a custom hook that was created to help with our integration from Firebase. This can actually be found in our context folder, which is something we were taught in our lectures, that if anything is to do with the users, it is better to store this as within context, and this is good industry practice. Anything in the auth context as a child has access to the user that we store in our sign up or login process. This hook manages the Firebase authentication state of the web application. It is a hook that uses useState as a callback to determine whether the user has a session already. It is a very simple hook that exposes the context as useAuth. We then created a provider component called authProvider, which is a component that wraps the children. This can be seen wrapping the majority of our components within our root component app.js, meaning that only those that have successfully logged in or have an account can only view the components between authProvider. We use React Router DOM as an npm package in our React application. This helped us to handle different routes in our React app by using dynamic routing. This shows that the React routing takes a component-based approach, calling on components to display the appropriate information. This also helps to create a more seamless experience for our users. In the front end, we also use Axios, which is a third-party library which is used to make HTTP requests from the back end of our application. It is also a promise-based library, meaning that our requests we were sending are either completed or rejected. Within our routes, Axios analyses the data we are sending and converts it to JSON. Axios also has a catch function which helped us to catch and console log our errors when a request was failing. This helped us to identify and perform root cause analysis of where the error was coming from. To test the requests we were sending from our front end, I used Postman to help with the validation. We decided to use Vercel to host our website. Throughout the project, we used Heroku and Firebase, which we could have used for deploying the website, but we decided to use Vercel, and this was purely to incorporate another technology within our application build, and because I also read up on the integration of linking it simultaneously to the GitHub repository. The deployment of Vercel was very easy and was actually a stage of the project that I was very worried about. It's a cloud-based platform which provides a free plan for hosting a static website. For the back end of our application, we decided to use Node.js and Sequelize because this is something we were taught throughout our time at Manchester Codes. The framework that we used for our backend was Express. This is one of the most popular Node web frameworks. I realised for the backend that I had to create a RESTful API which interacted with the front end of the application through the routes I mentioned earlier by sending and pulling data to the database. What I had to do with the backend was create a SQL database and host that database so the application had somewhere to store the data of tenants and packages. I also integrated a third-party API with the backend of the application called Twilio. This was an API that a previous group of students had used. It also had great documentation provided. The function of this API sends out text messages to the tenants when they have a parcel waiting for them at the concierge desk. Within the source of the backend, you can see we have our controllers and our models. The data models of our application can be viewed as a layer between the server and our database. The models are created to interact with our database by informing the database the type of data it should expect to receive. We only had to create 2 models for our application. This was a tenant and the package model. The tenant model captures all necessary data and also is essential for the interaction with the Twilio API. The package model is a very simple model which just defines the size of the package, if a tenant has been notified, and if that package has been collected. The way Ding Dong currently works from the user interface is a tenant can only have 1 package at a time. But if we were to scale this model, this would be an area that would need looking at from the front end. When building the Express API for our application, we use a third-party package called Sequelize, which is used as an ORM, Object Relational Mapper. This transfers data stored in relational databases into objects and helps to define the relationships between these objects. The relationships between the tenant and a package can be seen in our index.js file within the models folder. I did have a few issues with ensuring I'd created the correct relationship between the data. The relationship I did need was a one-to-n relationship, which can be seen in index.js. This means one-to-many. Throughout building the Express API, I again used Postman as a validation tool to ensure my routes were working. When it came to hosting the database, this was done on Heroku, and I used the ClearDB add-on to manage the MySQL database. I did, however, have some slight issues with Heroku. This issue was related to my environment file. In the backend, I had installed the .env zero dependency module that simply allows a storing of the configuration in the environment file. However, my Express API wasn't really my end file. I did find a workaround for this as I was running short of time, and that was by storing the actual variables needed in the user interface of Heroku. What I later realised was this is because of how I'd set up the environment file. I had to name variables with a specific naming convention, React App. Finally, how we used Firebase with the backend of our application. Firebase has many different services available, but we used it purely for the authentication of the users on the application. For the sign-in method of our application, we decided to use a simple email password sign-in. If we did decide to continue to work on Ding Dong and scale the application so it had a tenants interface, it also has the capability of creating role-based access control. The benefit of using Firebase for the authentication of our web application also means the security of the user's data does not fall with us for responsibility, and this meant we could focus on building a better user experience without having to manage the infrastructure or write server-sided authentication and authorization code. I really enjoyed working on the back end of the application and would definitely recommend the use of Twilio as a communication API. I'll now pass you on to Kallum to talk about our team's communication, problems and software development process.
I'm going to start by talking a little bit about the communication and coding practices we used while developing Ding Dong. Our main lines of communication were Slack and Google Meets. We used Slack, which I'm sure most of you are familiar with. We used it to stay up to date with each other and arrange meetings. For those meetings, we used Google Meets. We meet 2 or 3 times a week throughout the project. So for project management, we decided to use Trello. The way it works is you add a new ticket to not started, and then you move it along the line until it's completed. This really helps with accountability and also making sure you're not duplicating work. Setting the date also helps with keeping things on track. We also tried to incorporate a number of Agile development practices into our workflow. We met up around 2 to 3 times a week throughout this project. We started all of those meetings with a stand-up. We were already in the habit of doing so throughout our time in Manchester Codes. This just involved us checking in with each other, updating on any progress or issues we were experiencing with the work, setting any necessary actions based on those issues. We also use sprints, so setting ourselves ambitious but reachable targets to achieve for a given deadline, often centered around a specific piece of functionality. We also did some mob programming and pair programming during our meetings. If we were trying to figure out a certain piece of functionality on a package, for example, 2 of us could be reading the documentation and navigating while the other was driving and sharing their screen. Now I'll be covering some of the major challenges we faced when we moved into this freeform project that we had to build from scratch. It was certainly a shock to the system at first. But, after deciding on the processes we'd use and with the help of the tools and practices mentioned earlier, not forgetting a lot of support from the tutors, we eventually found our feet and got moving with things. Another challenging moment during that initial ideation was defining our minimum viable product, more specifically keeping it as lean as possible. So we started with a very clear problem to solve and all came out with real enthusiasm to design the perfect product. We had to be strict with ourselves and limit the project's scope given the time frame we were working under. So a lot of those features that we initially wanted to build ended up in the desirable but not essentials list. We totally redefined our MVP after the first week in order to get a handle on this situation. There were also some technical challenges that we experienced along the way. As Nina mentioned, we had an issue with Heroku and the naming conventions. Integrating the Twilio API with our backend was another problem area. This was because Twilio was built to integrate with MongoDB, but we were using SQL, and therefore we needed to implement an extra conversion step to get that functioning as we intended. The last technical issue I'd like to mention was cross-origin resource sharing, or CORS, as this was a consistent issue throughout development. It seemed to periodically kill our backend, but again, we've had to find a few different workarounds for that too. These are just a few technical challenges we faced, to be honest. There were a lot, and it took a lot of Google searching, questions on Slack, and a fair few Saturday sessions with the tutors to solve most of them. Now for some of the ways we would like to improve the app in future iterations. While we were well aware of the benefits of test-driven development, we felt so up against it time-wise that sadly we skipped this step. I think if we would have included TDD, this would likely have led to less bugs and better code design decisions throughout. So it's a shame we didn't, and we'd like to include that as the basis for any future work we did on the project. A major improvement that we were sad to lose when we scaled back our MVP was the implementation of a Tenant Side Ui. This would have been possible using role-based access control with Firebase, as Nina mentioned earlier. We even came up with initial designs for this. We had a login page, a calendar view, and parcel records, and a contact page. However, this was just one of those features that ended up on the cutting room floor during the scaling back of our MVP. Some of the other developments we'd like to add include the ability to remove tenants from the system within the app, upgrade on the UI so that we can display multiple parcels per tenant, and a detailed record of the parcels linked to each tenant. Another great addition, which we actually looked into, was email notifications. Twilio actually has a sister API for this called SendGrid, and ideally we'd have the option for a tenant to then decide their notification preferences. But sadly, again, this fell outside the MVP and didn't make the cut. This is just a taste of some of the functionality we have in mind if we do end up doing future iterations. That concludes our demo and presentation of Ding Dong. You can find us all on GitHub, LinkedIn, and Twitter, so please don't hesitate to get in touch if you've got any questions or would like to work with us in the future.